Good morning, everyone. I am Vinitha, Associate Professor in Triple Department, RMD Engineering College. Today, I am going to discuss a topic in power system transients. So, before going to discuss a topic, let us see the definition for power system. So, a power system is nothing but an interconnected network in which the components are connected one by one, which is used to convert non-electrical energy into electrical energy. And after converting this, the energy which is distributed to the consumers. Why this power system study is essential? So the power system study is essential to have a safe, efficient, reliable, and uninterrupted power supply to the consumers under both normal as well as the abnormal conditions. Let us see the general causes of power system transients. Lightning, heavy winds, trees falling across the transmission lines, vehicle colliding with towers or poles, birds shorting the transmission lines, aircraft colliding with lines, small animals entering the switchgear, and the transmission line breaks due to excessive loading. These are all the general causes of power system faults. Now, let us see what is the definition for transient. So, transient is nothing but the sinusoidal wave that deviates from its normal waveform whenever there is a sudden change in voltage or current. This may be occur due to any faulty condition or any sudden addition or removal of heavy loads or any power outages occur in system. And normally, the power system, which will be this is normally due to the sudden changes occur due to any lightning or any switching operation or whatever may be the changes in the circuit condition, the transients that may occur. And here, the voltage transients that may last for 50 microseconds and the current transient that may last for 20 microseconds according to ANSI C62.41 1991, and which is a standard for transient for the operating voltage less than 600 volts. And here, the transient phenomenon may be defined as an aperiodic function and which does not longer last for longer duration. Maximum, it may exist from a few microseconds to 1 seconds. And these transients, which may result in blackout a city, shutdown of a plant, or sometimes it may fires in the buildings and unusual power cuts, etc. So why these transients occur and what will happen if transients that persist for a longer duration? So these transients that may be created due to the presence of inductances as well as the capacitance in the circuit. So the function of the capacitor is nothing but during normal condition, both are nothing but energy storage elements that may store the energy. And whenever the switches or the circuit breaker contacts get opened, immediately the energy or the charge in the capacitance will start to discharge. So due to this charging and discharging of the inductances as well as the capacitances, these transients that may be created and these transients that may exist when the entire energy stored in the capacitances as well as the inductance may be damp out. And this is called as redistribution of energy. And these redistribution of voltages and currents cannot take place instantaneously. So this is due to the energy present in the inductances as well as the capacitance. And we know that in inductance, the energy which is stored in the form of electromagnetic field, and in the capacitance, the energy which is stored in the form of electrostatic field. And so due to these two energies, the transients that may occur and that exist for a small period of time. And if these transients, which is not cleared within the specific period of time, this may create a problem in the power system. And now let us see the causes of transient. So there are two main causes of transients in power system. One is nothing but the external causes. Another one is nothing but the internal causes. The external causes, which is otherwise termed as natural causes, and the internal causes, which is termed as switching transients. Let us see the transients one by one. First one is external transient. So the external transients are the sudden change in voltages occur due to lightning. So all of you seen lightning. So during lightning process, what will happen means there is an electric discharge that occurs between the cloud and the ground. And during that discharge, the voltage that will be discharged from the cloud towards the ground within very high magnitude, and this process that will be termed as lightning. And the second one is internal causes. So internal causes, as the name itself, it is there internal. So internal means during any switching operation, if the transients are created, that will be termed as internal transients. Normally, this will be due to opening and closing of the switches. And while comparing to the external transients, that is lightning, the magnitude of the internal transients that will be less. And these transients that may increase the system voltage to twice the normal voltage. And these switching transients may be reduced by providing the proper insulation in the system. And these internal causes, there are various factors which may produce the internal causes. And the first one is switching surges. So switching surges is nothing but the surges that may created while opening and closing of the switches or the circuit breaker contacts. That may be called as making and breaking of the switch. So what is making of the switch? Just connecting, that is normal condition. When the switch is in closed condition, that is called as making the switch. What is breaking the switch is nothing but opening the circuit breaker contacts or opening the switch. Okay. So while making and breaking of any circuit, that may create the abnormal voltages in the power system. And this may be due to the presence of inductance as well as the capacitance in the system. And here, the examples for these switching surges are given. Interruption of low inductive currents, like any transformer circuit, while interrupting the transformer circuit with low inductive currents. That is, if the magnetizing current is very low, it may create the switching surges. Similarly, while interrupting the small capacitive circuit, this also may create the switching surges. Similarly, ferroresonance condition as well as energization of loaded line. These are some examples of switching surges. Second one is that is here I have explained about this low inductive as well as small capacitive currents, and then what is meant by ferro resonance condition. So resonance, all of you know that the condition occurs when XL is equal to XC. Similarly, the ferro resonance condition which may occurs whenever the nonlinear inductances and capacitance which may present in the circuit. And here, the various possibility of occurrence of ferroresonance conditions are given here. First one is lightly loaded transformers operating in the presence of capacitance. Similarly, open transformer phases of both short and longer duration, unsynchronous switching of transformer phases, then use of voltage transformers without any damping measures, loss of system grounding, weak grounding or grounding through stray inductances, then use of voltage distribution capacitances in high voltage breakers. Similarly, use of capacitors in shunt and series compensation, use of shunt reactors with saturable magnetic cores. So these are some factors which may produce the ferroresonance condition. And these ferroresonance condition may lead to excess heating of the transformer due to the increased peak currents. So if the currents in the transformer increases, which may lead to increase in fluxes also. If the core flux increases, the temperature of the transformer may also get increases. If the temperature increases, which leads to the failure of the insulation. So these are all the effects of ferroresonance condition. So in extremely high voltage system, the first cycle of the ferroresonance can result in an insulation coordination problem involving frequencies higher than the operating frequency of the system. So generally the ferroresonance condition which may lead to insulation failure and the insulation coordination problem in power system. Second one is insulation failure. So all of you know about insulation failure. This may be due to excess voltage or excess voltage or excess current that may be produced due to various faulty conditions in power system. And here, some of the reasons that may given for insulation failure. The first one is nothing but aging of the material of the insulator. And the second one is the system, that is the insulation, which is accelerated by excessive heat and moisture content. And similarly, in the coastal areas, if you see, there is an formation of salt, formation of moisture, formation of dirt, etc. And due to that also, that may be a failure of insulation. Similarly, chemical formation, mechanical damage, sunlight, excessive voltage surges, this may produce or create the failure of insulation. Then the third factor is arcing ground. So what is mean by arcing ground? So in three-phase system, in star with neutral grounded, all of you know that during faulty condition, the excessive current that may be taken to the ground through the neutral system. So during that time, what will happen? Continuously, the charge will be discharged to the ground from the neutral towards the ground. So during that condition, due to excess discharge, there will be an arc produced. So these arc that may produce these arcing that may produce the system voltage to 3 to 4 times the normal voltage. Now, during this arcing system, what will happen means this high voltage, it may affect the entire power system because this leakage current, it is more than that is 3 to 4 times more than the normal voltage. Okay, so even though if the fault has been cleared also, continuously the current, the same current that will be flowing through the system, and we cannot stop this process. So this continuous process of discharging from the neutral towards the ground, that will be termed as arcing ground. And this arcing ground that may be prevented by means of proper earthing system. So these are all the basics of transients and the causes of transients occurred in power system. Thank you.